Can you all hear me and see me?
Yes, good evening. Yes, I can hear you.
Okay. Before we start, let me take about 3-4 minutes because we were expecting close to 100. At the moment, we have about 47. Let us take about 5 more minutes for everyone to log in. I'll come back to you. Please bear with us. There are about 22 people are still waiting in the list. So we are admitting one by one. Let us admit them as well. So please bear with us for another 2-3 minutes, please. Almost there, 4 more people to come in. Right, one more to come. So let us start. I apologize for the 12 minutes delay. We had to accommodate everyone. So I am Dr. Lalit Liyanage, Chairman IET Sri Lanka Network for this session. Today's topic is IET Wiring Regulations, the 18th edition. We have been conducting this session every year by IET so that new engineers and practitioners get used to the new wiring regulations. Very popular program. This is also known as BS 7671:2018. This was launched on 2nd July 2018. I will not go into much detail because our expert today, Dr. Asanka Rodrigo, will explore everything related to this topic. Let me just introduce Dr. Asanka S. Rodrigo. He is the Director General, Sri Lanka Sustainable Energy Authority, and a senior lecturer in electrical engineering at Department of Electrical Engineering of University of Moratuwa. Dr. Asanka Rodrigo is a senior lecturer in the department, and he is currently holding the position, as I said, Director General of Sri Lanka Sustainable Energy Authority on second-month basis. He obtained his bachelor's in honors, with honors in electrical engineering with first class honors, and MSc in electrical engineering from University of Moratuwa, and PhD in industrial engineering from the Hong Kong University of Science and Technology. Dr. Rodrigo has involved with many projects in Sri Lanka and overseas and in various capacities. He has also been with Asian Development Bank as a power and energy sector expert for many projects. Dr. Rodrigo is the president of IEEE Power and Energy Society, PES, Sri Lankan section, and senior member of IEEE. So far, he has supervised more than 45 Master of Science degrees, 2 Master of Philosophy degrees, and 1 PhD degree, authored 1 book and 2 book chapters, and published over 40 national and international technical papers. So this is a very brief biography of Dr. Asanka Rodrigo. So before I hand over to Dr. Asanka Rodrigo, the game rule is please switch off all your mics and videos. Let Dr. Asanka Rodrigo switch on his video and mic until his presentation is over. And meantime, you can raise whatever your questions on the chat box, so that at the end of the presentation, I will take your questions one by one so that we can save time. Otherwise, if everyone wants to talk, it will consume a lot of time. If there are burning questions other than ones in the chat box, you can speak as well. When you want to speak, please switch on your video and mic, introduce yourself and raise the question. I encourage you to put your questions in the chat box. So with that introduction, let me invite Dr. Asanka Rodrigo. You can see he's presenting his first slide. So Dr. Asanka Rodrigo, it's over to you. And after the presentation, we'll take up questions. Thank you. And please switch off your videos and mics. Thank you.
Thank you, Dr. Lalit. First of all, I would like to thank IET Sri Lanka section for inviting me to deliver this guest speech. So this is not the first time I'm delivering this kind of things in the IET. So even last time I did the similar presentation in a similar topic, so that the most of you are, I think, familiar with the topic. But in today's lecture, what I'm going to do is I'm going to introduce what are the changes, major changes which had happened in the 18th version compared to the previous version. So because in a 1 hour kind of a small lecture, it's very hard to deliver all the aspects in the IET regulation. For example, the IESL, we are conducting 8 days, the full 8 days session for the IET wiring regulation, so that you can consider how much of content is there. But in the today's one, what I'm going to introduce is what are the major changes and how they are affected to the design concepts, what we are following at the moment. So with that introduction, I would like to thank the Ravi Rupri Singh as well for the coordinating everything and inviting me for the sessions. I would like to mention his name as well. So I will switch off my video and I will go through the slides. But as the chairman said, Dr. Lalit, so if you have any question or any clarification, you can raise at any time. And also, sometimes I may stop the lecture and ask a few questions from you. So if you have anything to respond, you can unmute and the respond. I am expecting 1 or 2 answers if I ask similar kind of questions, because this is not as you know that I think most of you are aware about my lectures. I am conducting this type of talks with two-way communication, where even there will be a bidirectional communication, so that where we can share our knowledge and that will be benefited to everybody. So that is the way of the excuse the Dr. Lalit, I'll give some kind of a opportunity to the audience also, where they can respond for the some of the questions which I'm asking at the during my lecture.
No problem.
Yeah. Okay, so now, as I said, okay, this will be more like, as I said, a two-way communication. Now, in the topic, there's Dr. Lalit also the introduced. It's a IET wiring regulation, or what we call as a BS 7671. Okay, so now, as the name says, it's IET and the BS 7671. BS is British Standard. Okay, why we want to worry about the British Standard? Is there any requirement to worry about this one in Sri Lanka? If I ask that question, can somebody give an answer? Why we want to bother about the BS 7671? Because we can do our things in our own. Is there any requirement to follow the BS 7671?
I think it's always good to have some connection with the international regulations, because we consider that as a guide for us also to follow.
Yeah. So for example, if I want, if I am familiar with the US standard or some other Australian standard, can I apply it here?
I do not think we should mix up other the regulations of other countries, but it's best to keep to one standard, and the BS should be the one that we should comply with.
Okay, so
Dr. Answer is actually as Sri Lankan SLSI, they accept the BS standard for the Sri Lanka.
Yeah, exactly. So that it is not that, okay, we are just the following whatever the standard we are available internationally. It's because there is a legal provision in here. So because that's why we are worried about the BS 7671 or the IET wiring regulation, because when you look at the local standard, whatever things we do in Sri Lanka related to the electricity, that is governed by the Electricity Act. So that actually that was the first act was published in 1950 as a Electricity Act number 19. Then there were several revisions, and after introduction of the introduction of the Regulatory Commission or the Public Utilities Commission, that act was reorganized, and now the going as a Electricity Act number 20, which was published in 2009, and there was an amendment in 2013. With that one, the present status in the electricity sector is whatever things we do, that is power generation, power transmission, power distribution, and power utilization. So that utilization is here what we are talking about, that is how we are going to utilize the electricity. So whatever things we do related to the electricity, we have to follow. We have to follow this, the Sri Lankan Electricity Act, because it's an act and it's the law of the country. So that is the passed by the parliament, so that it's a law. So that when you look at that one, is there anything said about the BS 7671? Okay, because we have to do whatever anything what we do in Sri Lanka related to the electricity as per the Electricity Act. Is there anything related to, okay, is Act mention anything about the BS 7671? Any idea? Actually, the Act does not say anything about the BS 7671. So then, okay, somebody can ask, okay, why we are worried about the BS 7671, as I said. But as per the Act, because when you have an Act provides certain type of the regulations. So that in Sri Lanka, we have this electricity regulation of 2016 that is published under the Act, because the Act provides certain can provide certain rules and regulation. So that this is a regulation, electricity regulation, that goes as a electricity safety, quality, and the continuity standard, which is published in 2016, is a gazetted one. So that it contains several safety regulations. Under this one, now it is clearly mentioned that we have to follow BS 7671 or the IET wiring regulation until the SLSI publish certain our own thing, or if the SLSI overrule the requirement of the BS 7671, then that will be there. Until such time, we have to follow. We have to follow. I'm saying because there is no any other option, because it's a law. It's a country's law. So this is the part which is given in the the Gazette. So that as per the this regulation, we have to follow. So no one cannot argue about it. It's a must. So that it's a country's law, where until we publish our own standard, or until the SLSI publish our own standard which overrule the BS 7671, till that time we have to follow the BS 7671. It's a legal requirement, so that we have to follow. That's why we want to worry about this one, because if we do not follow this, the standard, it's a violation of the country's law, because that is governed by the Electricity Act. So the regulation is made under the Electricity Act, so that this is also a rule, the law in the country. So that's why now it is not that, okay, anybody can argue that I can do whatever things I want in electricity or the utilization. No, that is not where we have to do all the design, everything related to the electricity utilization as per the BS 7671 or the IET wiring regulation. That is the legal status in the country. So before going into the detail about the 18th edition, I will give you a brief introduction about what is this IET wiring regulation or the BS 7671. So actually this the BS 7671, even though now we are the calling as the requirement for the electrical installation, actually that was started as the rule and regulation for prevention of fire risk arising from the electric lighting, because at that time in 1882, at that time the major issue related to the electricity or the electricity was the lighting, because at that time people knew that the lightning is an electrical activity, and because of that the lightning make a lot of the damages to the buildings and the structures, so that actually the regulation start with that type of intention. But the later, the time to time, there were the several revisions. Those the went as the editions, so that I'm not list out all the editions, but I am telling what are the major the changes in the regulation, so that in 1897, that is in the third edition, the name was change as a general the rule recommended for wiring of the supply of electric energy. So that, and then in the fifth edition, so since the name is too long, so that was shortened and just said it as the wiring rules. That is 1907. Then there were several amendments from time to time. And then the 8th edition was published in 1924 as a regulation for electrical equipment of building. So that you can see how it changes from time to time. So that the name of the regulation was regulation for electrical equipment for buildings. Then, so the major change was happened in the 15th edition. Then there were several editions in between. And in 15th edition, that was named as a regulation for electrical installations. So that is in way back in 1966. This is the time where even we had our Electricity Act, and the people, this electrical construction was started in Sri Lanka. There were construction even before. So that this is the time even we the accepted this BS7, the IET wiring regulation as our own standard. Even the IESL and other institutes then promoted this one as a standard. So conducted several CPDs, those type of things, and that was promoted in Sri Lanka. And in 16th edition, which was published in 1991, at that time this was very popular, and all the people who were in the electricity sector about the IET wiring regulation. And then even for there were several amendments. And in the 16th edition is the where we got the new name, that is the requirement for electrical installation. So we are now still we are following the same name, but you can see in 16th edition there were several amendments of the publication in 1991, 94, 97. So they came as a different colors of the books. And in the 2001, that was the last one in the 16th edition, the published as a brown color, the booklet. So these are the old versions where from time to time there were different type of the booklets like that. And in the 17th edition, the 17th edition was published in 2008. So that is with a red color, as I shown in the lecture slide. So that it's a red color book. And then there were several amendments in this 2008 version from time to time. First amendment happened in 2011, and that booklet was published as the green cover one. And you can see in here, there is an amendment number is mentioning, so that the BS 7671, and this goes as an amendment number 1 of 2011. And then there was a second amendment in 2013, which was published as a yellow book. And here you can see now amendment number 1 and amendment number 2. Both are there in the this version. Then in the last amendment was happened in 2015. You can see the amendment number, all amendments are listed out here, BS 7671. So you can see there are all 3 amendments are listed here. So that is the last one, which was published in 2000, in 17th edition. So then people realize that the technologies are changing drastically, and they want to incorporate more and more new items, so that rather than having another amendment, so the new version was published as the 18th edition in 2018. So that now we are going as the blue color book. Now you can see it's going as a BS 7671, the 2018, no amendment, nothing up to now. So that it's the current version which we have to follow even in Sri Lanka, even though the regulation published in 2016, at that time we had the 17th edition. That's why the 17th edition was listed there. But it says 17th the edition or latest one. So that now, as per that regulation, we are bound to follow the 18th version as well. So that whatever electrical installation we are doing in Sri Lanka should follow this, the BS 7671. That is the legal, the background in here. So when you look at this, the regulation, the wiring regulation, that is based on 2 standards. One is the European Commission electrotechnical standard, and the other one is the IEC standard, which normally we follow most of the other kind of the requirement. So the IEC standard, International Electrotechnical Standard. So that the combination of these two, because even in the 18th edition, especially like a testing and other things were directly taken from the European Commission electrotechnical standard, so that the tables and the charts, everything were adapted from there. So that it's basically the BS 7671 follows the IEC wiring IEC standard, as well as the European the technical standard. And the earlier version, as I said, there was the 2008 one with the amendments, but now we are following the 2018 version. This one, as per the rule, so we have to follow this one from 31st of December 2018. That is the 1st of January 2019 onwards. We have to follow the 18th version. So that whatever the design we do here, and the whatever installation we do, the conduct here, so that that should follow the 18th version. So that is the requirement in Sri Lanka. Now, when you look at this regulation, so the sometimes people think that this is the standard we have to follow. But it is not like that, because when you look at the electrical nowadays, the electrical installation, that complies with the many things. So that when you look at the IET wiring regulation, that basically regulation applies to design. You can see the selection, erection, inspection, and testing of electrical installation. And also it clearly mentioned that, okay, what type of installation you have to apply the IET wiring regulation, and where we cannot apply the IET wiring regulation. So that when you look at the residential, commercial, public or industrial premises, or any construction site, exhibition, or temporary building, or even a highway, which the normal supply is less than 1000 volts AC or 1500 volts DC. So that there is a limit. So that the voltage should be less than 1000 volts AC and 1500 volts DC, as well as it should be residential, commercial, public, those type of installation or construction site. So then we can apply this regulation for that type of location. But the regulation clearly mentioned that even though the voltage is less than 1000 volts AC or 1500 volt DC, so this regulation is not applicable to the supplier's work. For example, like the utility, CEB or LECO distribution system, you cannot say, okay, our regulation is this, you have to follow that one, because when you look at the distribution codes are there separately, even in Sri Lanka, where the utility should follow those codes. So those are separate one, which are not covered by the IET wiring regulation. And also the railway, rolling or signaling equipment, the ships, aircraft, even though their voltages are the low voltages, you cannot apply this regulation for those type of things where they have their own separate standards. So that we cannot apply this one, even though their voltages are the below 1000 volts AC or 1500 volts DC, we cannot apply IET wiring regulation for these type of locations. So now, as I said, the main the criteria for selection is the voltage level, because when you look at this, the BS7671, it gives the rules and regulation to reduce the risk of electrical hazards. So that here, as per the IEC and the BS7671, there are 3 levels of voltages that are defined. There are subcategories as well. Those are the low voltages, the extra low voltages and the high voltages. So that the lowest one is the extra low voltages, where the voltage is 50 volts AC to AC, less than 50 volts AC or 120 volts DC. So that here the main thing is we have a minimum risk, so that the risk of electric shock is very minimum if you expose to this type of voltage. That's why they are considered as an extra low voltage. And within the extra low voltage, there are special voltage categories as well, even less than 12 volts or less than 30 volts, especially for the bathrooms, the swimming pools and the sauna, the heater locations, those type of locations, there are special requirement that you have to use the extra low voltage, but even lesser than these voltages. As I said, there are subcategories within these things, but we categorize them if the voltage is less than 50 volts AC as an extra low voltage. Then we have the low voltages, that is 50 volts to 1000 volts. So in that case, if you expose to that type of voltage, so there is a risk of electric shock, so that there will be a current flowing through the body, and due to that current, if that current is sufficient and if you expose to a sufficient time period, then that person can get electric shock. So there is a risk of electric shock. And the third category is where the high voltages. If the voltage is more than 1000 volts, those are considered as a high voltage. In that one, if you expose to that type of voltage, not only electric shock, but there will be a electric arcing as well. So that because of that, there is a very high risk, and the regulation do not cover that part. That is, the high voltage is not covered under the regulation. Regulation basically covers the low voltage and the extra low voltages. So now, when you look at the objective of the regulation, so the main objective of the regulation is to the protect people. The regulation gives the highest priority to the people and the property, as well as the other type of livestock like animal, those type of things. And all basically we are going to, as I said, the minima is the electrical hazard. So those electrical hazards are listed as a electric shock, the fire, and the burning, or the injuries due to the mechanical movement of electrical equipment. So those are the hazard what we are trying to minimize or avoid by using this the IET wiring regulation for low voltage applications. So now, when you look at this IET wiring regulation, there are actually that is structured in a certain manner where there are the part numbers. Normally, when you look at a book, so that you have chapters at the topmost layer, but in here in the regulation, what we have is a part. So there are 7 parts in the regulation. When you look at, if you look at the 16th edition and the previous one, where the special installation were under the parts 6, and the inspection and testing was under the part 7. But from the 17th edition onwards, now it was changed where special installations were listed in the part 7, and the inspection and testing is listed under the part 6. When you look at the structure of the regulation, that structure gives us like this, where the topmost part is the part number, then we have the chapters in a certain part. Let's say if you take the part 4, there are several the chapters, chapter 1, chapter 2, chapter 3, those are going as a chapter 41, chapter 42, the likewise with the part number. Then you have the section numbers, sections, and then you have the subsection, and under the subsection there are regulations, there are multiple regulations and the multiple subsections as well. So that that is the structure, where the regulations are listed in the IET wiring regulation. So now that is the basic overview of the IET wiring regulation. Why we want to follow the IET wiring regulation, how it came to the current the current the standard like that. Now let's look at, okay, what are the key changes in the 18th edition compared to the previous ones. So that there are certain extension in the regulation, especially. So there were new addition to the special locations. The part 7 is the special location. So that there is the new addition for the onshore, the electrical, the units the connected to the shore electrical, the things where for example, if you have a vessel, sometimes we want to connect a vessel to the land electrical system. When you are connecting them, what should be the rules and regulations you have to follow in that type of the connection. Those are the new things added, and there are a few amendments within the regulations as well. So these are the major changes. So which we can, there are other minor changes here and there. A lot of minor changes are there, but the major changes are listed here. So that, for example, chapter 41 and 42, there is a significant changes in the numbers, and they were restructured, and the numbers were significantly changed, and the regulations were altered, and that type of things were there in the 41 and 42. And when you go to chapter 44, so it's completely different. Now there is a redrafted new the chapter 44. So it's a completely new the chapter. And when you look at the chapter 46, so that is a completely new one. It's a new addition. So that the 44 is the revision, where the 44 was there in even in the 17th edition, but it's a redrafting. But the 46 is a new addition. And again, there is the 53 is already the revised, and it's a completely revised, similar to the 44. And also in the part 6, there is a restructuring of the part 6. As I said, part 6 is the testing and the inspection and testing. So that they have adopted this European Commission standard in the IET regulation. So that now all the new the formats are given. All those formats are adapted from the European the standard. So those are the new additions to the 18th version. And the chapter 61, 62, and 63 is the completely the deleted, and the new chapters were added as the 64 and 65. So those are the major changes that was happened. And also now when you look at any electrical system, we are talking about the energy efficiency, because we know that the energy is the scarce the resource, and the resources are depreciating, and because of that we want to reduce the energy consumption, and we want to minimize the losses. And because of that the new guideline or the appendix is given as a guideline note for the energy efficiency for the electrical installation. So it's at the moment as a guideline. Probably in future that will also comes as a the standard, but at the moment it's just a guideline where the designer can look at what are the requirements, and they can optimize their design by considering the energy efficiency as well. So I will briefly explain the few such the changes, major changes happen in the standard. So that as I said, the chapter 41 is the change. There were several changes in the chapter 41. When you look at the first change is when you look at whatever the electrical or whatever the metallic connections coming into the building. So this is our building. So there can be many metallic connections or metallic pipes which are coming in. Most of the times in Sri Lanka, we are getting even the water pipes and other things as the PVC pipe. Then this is not really matter to us. But most of the other countries, they are getting the water and even the gas as a metal pipelines. So if you have a metal pipeline in the earlier version, we have to connect this metal pipeline to our equipotential bonding. But now what they are saying is you don't want to worry about the outside the building, even though the metal pipeline is coming into the building, but your connection from the building or the starting point of the that metering point to your installation is a non-metallic, then you do not want to connect the whatever the metal part outside the building to the earthing system, so that equipotential bonding. So that is a major change, because earlier, so even though you have this type of a PVC connection, this part you have to connect to the equipotential bonding. So now in the new regulation that was removed, so because outside the building you don't want to worry, and that can make a lot of complication if you consider, because you don't know the which type of connection is there in this part. And because of that what they said is if you are connecting this pipeline through the non-metallic pipe, then you don't want to worry about this part. But if it is continuing as a metallic pipe, then you have to connect to the equipotential bonding. So that is one of the major change happen in the regulation. And also there is another requirement for the luminaire. So if you are supplying the light fittings for the building through which is the light fittings, then we have to protect them using a RCD where the I delta N should not exceed more than 30 milliampere. So that is its operating current should not exceed more than 30 milliampere. Where sometimes you may experience that especially with the LED and other things. So since there are a lot of the harmonics and other type of issues, people were trained to use the high the operating current RCDs, something like 100 milliampere, some installation like the 300 milliampere, like that. But as per the new regulation, you cannot go like that. So where the luminaires, you have to the supply through the 30 milliampere the RCD. So because especially like the households, so where you cannot go with the more than 30 milliampere, you have to wire them through a 30 milliampere the RCD, because earlier only the socket outlet should be wired using 30 milliampere RCD, But now not only the socket outlet, but also the luminaire should also be wired using a 30 milliampere RCD trip switch. Then there are certain the additional requirement for the socket outlets as well, so that in here the socket if you are supplying any socket outlet where the rated current is less than 32 ampere, then it's compulsory to wire them using 30 milliampere RCD. So either socket outlet, or even if you have a mobile equipment where its rated current is the less than 32 ampere, then you have to wire them, or you have to protect them using 30 milliampere RCD. So now these are the new additions to the regulation, to give the additional protection or additional requirement. And here, when you look at this one, this rule is not applicable if you are going with the FELE, that is the functional extra low voltages. Sometimes there are certain the location where we want to extend our earthing system for the extra low voltage system as well. So that in that case, if you are following the functional extra low voltage, then you don't want to stick to this rule. That is the only exception. Other than that, if you have any circuit with less than 32 ampere socket outlet or 32 ampere mobile equipment, then that should be protected with the less than 30 milliampere RCD. And also there are certain omissions. RCD omissions are also included in the regulation. So that is also an additional part which we can omit certain RCDs in some other locations. And also there is a major change in the tripping time of the RCD, so that when you look at the earlier version, so the tripping times were subdivided into two categories: the circuits less than 32 ampere and the circuits more than 32 ampere. The circuit less than 32 ampere, so this table should follow, where depending on the voltage level, so either, for example, if it is less than the 230 volts AC, so which we are using. So if it is a TN system, then you have to have the RCD, the earth fall protection should be less than 0.4 second or 400 millisecond. If it is a TT, it's a 0.2 the seconds or 200 millisecond. Now this is extended up to 63 ampere. So if it is a final circuit with one or more socket outlet and up to 63 ampere, now this rule should apply. So earlier it was only up to 32 ampere. After 32 ampere, you can go up to, if it is TT system, up to 1 the second, and TN system up to 5 seconds. But now this is extended up to 63 ampere. So you have to follow this the maximum disconnection time for the earth falls. And also there are certain the major revisions and the new regulation added to the standard, so that when you look at this 419 is the complete new section added to the standard. It's a new section, and as per the earlier version, when we want to have the protective measure, if you say the protective measure is defined as you have to provide the basic protection. So now we are not using the term the protection against direct contact and indirect contacts. So the basic, what we call as a basic protection, now it's a compulsory protection requirement. And then you have to have the equipotential bonding and the automatic disconnection. So as per the 17th edition, that was the requirement. But now the later people realized that in the 17th edition, even though that mentioned as a compulsory requirement, now there are a lot of electronic equipment where they cannot follow this requirement. So that because of that, the new section was added with the new regulations, or the new regulation numbers, especially for the locations where you cannot apply this one, where the disconnection time and the requirements, if they are not feasible, then what they are telling is, so the new two regulations were added where if there is a fault, you have to reduce the supply voltage less than 50 volts or 120 volts for that type of circuit or the electronic circuit, or else you have to have a the supplementary bonding. So normally you have to have the PE conductor for all the equipment. It's a mandatory requirement. But if you cannot satisfy with the automatic disconnection requirement mentioned in the regulation 411, so then you have to have the supplementary bonding, so that you confirm that there will be a equipotential in everywhere, so that not only the preliminary or the PE conductor, but also there is a supplementary bonding as well, so that you are confirming that the entire installation is with the equipotential bonding. So that is a new addition to the standard. And also there are the new addition that is for the protection against thermal effect. So as per the new, this is a completely new one, where the earlier version they were not talk about this one, where now they are introducing new the protection requirement as a fault detection, the arc fault detection. So the arc faults are where even when you switch on and off the switch, you can see there is a small arc inside the switch. So those are the arcing. So that, but if there is a sustained arc, so that can create fire hazard. So that the fire hazard. And because of that, people realize that this is a major issue. When you look at in traditional way, we were talking about the MCB or the overcurrent protection and the earth fault protection or RCD. That is the normal requirement with the equipotential bonding. But people realize that the arc faults are not detected by any of these equipment. And because of that, new devices were introduced like arc fault protection devices, AFDD. So that is for the final circuits. And now normally we know that if there is a live to neutral connect, the short circuit, then that will be detected by the MCB as usual. That is the usual overcurrent protection. But if you have the arc fault detection device, that also detect this type of fault. That is what we call as a parallel arc faults. And also there can be the live to earth. That is a earth fault. So for the earth fault, traditionally we are providing RCD. So that will take care of the earth fault. But the arc fault detection devices can also detect this type of, if there is an arc, that will be also detected by these devices. But when you look at the third type, that is the series, the faults. That is, there can be certain type of disconnection or loose connection, those type of things where that can create sustained arcs within the installation. So when you look at even MCB or RCD or any other device, they will not detect this type of arc fault, and the people realize that okay, this will lead to the fire. And because of that, in the new regulation, the new device is introduced as a arc fault detection device. So that the third category only can be divided by the arc fault detection. That's why that is introduced. And these are the similar kind of devices. And as per the new regulation, there are certain locations where the regulation recommend to have arc fault the detection devices as the compulsory requirement, like the sleeping and the accommodation location, like for example hotels and those type of locations, it's recommended to use arc fault detection. And if there is a fire risk, and especially like the BE2 category. BE2 is external influences, risk of external influences. Those are categorized as BE1, BE2, BE3, BE4, like that. BE3 means where there is the risk of fire, and if you have a certain location with the risk of fire, then you have to go with the arc fault detection. And also if you have certain combustible the construction material, like wooden buildings or similar kind of things, then you have to go with the arc fault detection devices. And also if there is the location where the fire can propagate through the structures, then again you have to use this arc fault detection equipment in those type of location. This is a new addition. So for the regulation, normally we know that when you look at normally we are telling to go with the circuit breakers and the RCD, but now there is a new requirement. You have to evaluate whether there is a risk of arc and what type of the location is that, and if the location belongs to this type of the location, then you have to go with the arc fault detection. And also there are certain type of requirement for the voltage disturbances as well, and the electromagnetic disturbances. Now when you look at our electrical equipment in a building, you can see there are a lot of the electronic equipment, and which are working with very low voltages, as well as some of them are working with the high frequency the kind of things. So especially most of nowadays power supplies are switch mode power supplies, where their switching frequencies are very high, so that they create a lot of electromagnetic disturbances which were not discussed the 10-15 years back. These are new requirements because of the introduction of new equipments. Now the people are getting more and more new problems, and because of that what they are telling is in order to avoid, and also now most of our electrical equipments are highly vulnerable for voltage disturbances, and because of that you have to have a certain type of the over voltage protection as well, so that in the new the requirement is introduced as a chapter 44 as a voltage disturbances as well as the electromagnetic disturbances. So that what they are telling is, so that you have to assess the risk, and then depending on the risk assessment, you have to propose over voltage for the location, over voltage protection for our building. So, and also when you look at the new the standard that introduces a simplified version of the risk assessment as well. Normally in the over voltage protection, that is covered under the lightning and the IEC the 62305, but that is adapted in the BS 7671, and a new simplified the risk assessment is given here, so that it's where when you are designing any new the installation, you have to calculate the risk level, risk of transient over voltage, and depending on the risk level, you have to put the transient over voltage protection devices. So when you look at this risk calculation, so there is a equation given where you have the F environment, that is the environmental factor, divided by the LP. LP is the conductor length or the cable length, and the NG is the lightning probability in that area, so that the lightning will create the highest or the risk to the over voltage, and because of that they have adapted this as the risk assessment. So it's a very simple equation where anybody can use this equation and find out what is the risk level of that particular the installation. So what it says is, if this CLR is more than the 1000, then you don't need such protective devices, and if the risk level the CLR is less than 1000, then you have to have the surge protective devices. And if you are not calculating risk, then it's a compulsory to use surge protective devices. That's what the regulation says. So now that is a new requirement. These are new additions to the regulation. So that the risk calculation is very simple, as I said, because there is an equation to calculate the LP value. So the environmental factor, you can consider whether it is urban or rural the installation, and the line length, what is the length of the overhead line, what is the length of the underground cable, what is the length of the high voltage cable. You can consider all those things, and then you can calculate this LP value. So when you are calculating that one, you consider maximum length of the 1 kilometer length. So that is this this length component. We are considering only up to 1 kilometer length, or the whatever location where you have the over voltage protection. For example, when you look at distribution transformer, in the high voltage side of the distribution transformer, you have the surge protector or the lightning arresters. So then you have to consider from that point to your installation, what is the total length. So even that one, you should not consider more than 1 kilometer. Maximum is the 1 kilometer. What is the total length, the component within 1 kilometer, you can put to this equation, and then you can calculate what is the LP value. So that is the length parameter of the risk calculation. So the other one is NG. NG is the what is the lightning flash density in a particular location. That also you can get from the meteorology department maps. What is the Sri Lanka's the lightning flash density in different location. So then you can calculate what is the risk level. So this is the examples given in the new regulation, so that you can calculate these NG values and the environmental factor. So like that, it's a very simple calculation. Anybody can do it without any problem. So that we can check whether we need SPD or the surge protected devices or not. So that is this part is completely new addition, and also the surge protective device, there is a new addition. So that is covered in the 534. That is for the devices for the protection against over voltages. This is also the completely new the section added to the new regulation. When you look at the earlier version, 17th edition, so this is what is in the 17th edition. You can see very simply the one sentence, and in the 534 is not used. It's totally a blank one. But when you look at the 18th version, it's a completely new section. So there will be there are several pages of the regulation. So this is the first page. Likewise, you can see now 534 is newly added things to protect our installation against transient over voltages. So now that is the BS 7671 basically adapted the IEC 62305 standard, so that also gives us the zone, the lightning zone and the zone protection. So here also we have to follow the zone protection. We have to subdivide the electrical installation into the different zones depending on the risk level, and then each interface from zone, let's say the zone 0 to zone 1, zone 1 to zone 2, zone 2 to zone 3. Likewise, those interface location, we have to put the surge protected device appropriately. So that is a new addition to the standard. Now, when you look at this, the SPD selection, there is a very comprehensive SPD selection criteria is also given in the standard, which was not in the earlier version. So that likewise, you have to have the type 1 or type 2 at the first, the one where the basic concept is, when you look at this, the SPD selection, so that if a surge comes like that, the major component of the surge will divert it to the ground to the first one, but there will be a remaining small amount. So that normally the 90% of the surge will divert to the first one, but there will be about 10% goes to the next part, and out of this 10%, then there will be 90% of that. That is the 9% will go from the second one, but there will be remaining 1% will go to the other part. But if you have a additional surge protective device, then you can see the almost 0.9% will go there, and 0.1% will go to the other side. So that when there is 100% comes like that, you can see that finally equipment will see very small amount of surge over voltage, so that we can minimize the damages that can happen due to the surge over voltages in our building. Because now why the standard is highlighting this one is now we are using more and more power electronic based equipment. Now when you look at the something like 10-15 years back, we were using incandescent lamp. Now we never use incandescent, but they all were replaced by the LED. And when you look at even the fan or any other equipment, all are now coming with electronic drivers and electronic equipment where they are very much vulnerable to the over voltage situation. So that now this has become a mandatory requirement, not like earlier installation. Now the new designs, you have to evaluate the risk, and then you have to incorporate the transient over voltage protection for the building design. And this is the summary, because as I said, there will be the few pages of the regulations. So when you look at the summary of the SPD selection, what they are telling is you have to have the type 1 for the origin of the installation, and the type 2 at the distribution board, and the type 3 at the terminal level. So that if you use this type of a cascaded arrangement, you can minimize the lot of the over voltage damages, transient over voltage damages. And also there are a few other requirements in the low voltage application. So that we have to use your voltage protection level should not exceed more than 2.5 kilovolts. So that is a mandatory requirement. And for the critical equipments normally, so that is those are considered as a category 1 equipments. So where your UP value should not be the more than your the insulation level. So that generally we are saying that our insulation level as UW, when you are selecting your UP value should be less than or equal 0.8 times other way around. So that the UP value should be less than or equal 0.8 times UW. UW is your insulation level. So depending on the category of your equipment, you can find out what is the insulation level, whether it is the 800 kilovolts, or whether it is 1.5 kilovolts, or whether it is the 2.5 kilovolts, or whether it is 4 kilovolts or 6 kilovolts. Depending on that, there are different categories of equipment. So that depending on that, you have to select your the surge protective devices. And also there are certain requirements when you are going with the class 1 SPD. So the SPD value, the I impulse should not be less than 12.5 kilovolts. And also the when you are having the single phase and the 3-phase, if you use 12.5 kilovolts coming in, so that that should go through them, you will get 4 times 12.5. So that is 50 kilovolts. Minimum should be 50 kilovolts. If you get the single phase, you will get 2 times 12.5. So that it's the 25 kilovolts. Those are the minimum requirements. So there are the regulations for those things in the new standard. And also, so the standard recommends to use certain type of connection patterns. Normally when we are using SPDs in the installation, we can use 2 arrangement. The first one we call as a 4+0 arrangement, CT1 arrangement. Second one we call as a CT2 arrangement. So the way are 3+1. You can see there are 3 SPD, one from the neutral to earth. And other one is where all 4 the lines, the 3 lives and the neutral, you are getting 4 SPDs. So that when I ask, if I ask what is the best way, so whether the first one or second one, you recommend to go for our installations. What do you say? Now you have 2 options. Either you can install your SPD as a type 1 or the CT1 or CT2. Which one you recommend?
CT2.
Any answer?
CT2.
CT2. Why CT2?
Because
Why?
for the protection is here.
The protection is the CT, because when you look at normally our installation, we have TT arrangement versus the TN arrangement. So when you look at the TT and TN, so actually your connection pattern will depend on whether you have a TT arrangement or TN arrangement, and also the what type of protection you want to have, whether you want to have a common mode protection and the differential mode protection. So if I use this one, the first type in a TT arrangement, what is the problem? So if I say the first type is not recommend to TT arrangement, so if I say like that, why is that? Can you imagine why the first arrangement is not recommend for the TT arrangement? Any idea?
Short circuit.
Okay, if I give a hint, so whether you use the SPD before RCD or after RCD, what is your recommendation? Whether to use SPD before RCD or after RCD?
Before RCD.
Okay, so if I use the first arrangement before RCD, what will happen in a TT? So you can see, for example, if there is a fault in one SPD, so what will happen? So that there is a connection, so like that, sorry, like this, will go to earth. But in TT, so this is going through the ground return. So where you have a very high loop impedance. So what will happen? So will the overcurrent protective device will detect this type of a situation? Obviously not, because now this leakage current is very small in a TT, because that will return through the ground, so that our overcurrent protective device will not detect that type of the fault, so that there will be a sustained earth fault in the system, which our overcurrent devices in the upstream will not detect that type of a situation. So that because of that, this system is not recommended to the TT arrangement, where you can go with this one. If there is the fault in one SPD here, you can see the fault will go like that. Because of that, what will happen? So that will be detected as a short circuit, because the neutral there is no SPD in the neutral connection, because here the problem is you have a SPD in the neutral connection, so that it's like an open circuit. But in here, it is already connected, no SPD, so that if there is a short or the leakage in the SPD, that will be detected as a short circuit, so that the upstream protective device will detect that one and cut off the circuit. You will not get sustained earth fault situation if you connect it like that. That's why we are recommending this arrangement for TT. But for the TN arrangement, you don't want to worry about that one. So even here, so what will happen is in the TN arrangement, you have PE conductor. So because of that, the fault current will flow to the PE. The fault current will not be the smaller like in the TT arrangement. So that even if we can confirm that upstream protected device can detect that type of a fault, you can go ahead with this type of a connection for the TN system. But for the TT system, this is not recommended if you are using it before the RCD. But if you are using it after the RCD, then you can go ahead with this type of arrangement as well. So that in the new regulation that gives the recommendation how to use this different connection patterns, you can see in a TT arrangement, the first type is not recommended. If you are using the first type, you have to use only after the RCD, that is downstream of the RCD. And when you are using the downstream of the RCD, there are other requirements, like they have to have the width and immunity of 3 kiloampere, at least 3 kiloampere, and you have to use the type S RCD. So likewise, so those are the requirements. So those are new additions. So to the 18th version. So but you can see here. So for the TN system, you can the CT the type 2 arrangement, you can go with the whatever the connection pattern. So that now you can see when you look at the consumer unit or the distribution board, in the future distribution board. So now, as I said, now the new regulation introduced the surge protection as a compulsory requirement, and the arc fault detection as a compulsory requirement for a certain installation. So that because of that, now the design will be completely different. So not like earlier we were discussing about only the RCD and the MCB or MCCB. But now there are new requirements other than the RCD and MCCB or MCCB. Now you have the arc fault detection as well as SPD. So that the consumer box will be, especially the final distribution boards will be the different for the future the things. So that you have to consider them, you have to evaluate them, and then you have to design it as per the new requirement. So that these are new things where you cannot go with the traditional way as you did in 4 or 5 years back. Now you have to comply with these new requirements. And also there are certain earthing arrangement, the requirements due to the time limits. I'm trying to minimize these things. And these are some of the arrangement where now the new standard encourage you to go with the equipotential bonding, and even for the foundation earthing and the common earthing for the buildings, so that you can design from the beginning where you can have the foundation earthing. But when you are going with the foundation earthing, you have to consider the corrosion and other things, so that those new regulations are added for the corrosion prevention, the similar. And also if you have multiple sources of in a building, so that then how to do the earthing arrangement. Sometimes most of the times people are asking about, okay, if you have multiple sources, 2 generators in 2 locations and feed into the one installation, and 2 transformers are feed into a 1 location, what should be done for the earthing arrangement, whether we want to connect them together or whether we want to isolate them. Okay, what type of earthing should be there? Those new regulations are added to the standard, so that you can refer them. These are the few new new requirements added to the standards. And also, as I said, because now the standard recognize that these electromagnetic disturbances are very common in most of the installation because of their the equipment behavior and the equipment pattern. And because of that, this equipotential is highly encouraged, and it's given as a mandatory requirement. So we are like in early days, people were talking about your power earth, your telecom earth, your lightning arrestor earth, blah, blah, blah. Likewise, okay, the clean earth, dirty earth, likewise, the different type of earthing. Now those concepts are no longer applicable. Now the new standards are not recognizing them like that. What you have to have is a equipotential bonding, so that you have to have a same potential, even a lightning arrestor, even the telecommunication, even your the power earth, everything. You have to have a equipotential where you have to have a same the potential in everywhere within the premises or building. So that one example is like that, you can refer the standard so that will give very good the detail, the description about the equipotential bonding, so that you can see even if you have a multi-story building, you can have a structural earthing and the the foundation earthing, so that everything will be connected together. No different earth. You don't want to run separate earth, but it can be connected to a common earthing arrangement, so that everywhere you are getting the same potential. So that is the basic concept, so that that will minimize the electromagnetic the interferences as well. So that in order to minimize the interferences, you have to have the equipotential bonding. So that is the requirement for the new regulation. And also now there are different type of the services, like you have the power, the cables, you have signal cables, you have instrumentation cable in the same premises. And also in the new regulation, there is the guideline, or there is a requirement given when you are running these cables in parallel, what is the minimum separation requirement. So that depending on the voltage level or depending on the current value, the minimum separation requirements are listed out in the new regulation as a new table, so that you can see. So because of these interferences, because we want to minimize the interferences. Now there are a lot of interferences happening from power line to the instrumentation, because a lot of the equipments are now generating harmonic and high frequency harmonic, where they are giving certain type of electromagnetic interferences. So to minimize that one, so now the standard says us if you are running with different type of services like that, where you have to have a minimum separation between those cables, those minimum separations are given with the power to signaling cable like that. Those are new additions to the standard. And also, as I said, because now there is a new appendix. So when we are designing our electrical system, we cannot just consider the safety aspect. We have to give the first priority for the safety aspect, but also we have to optimize our system such a way that there will be energy efficiency, and we have to minimize the losses as well. So that at the moment, this is given as a guideline, but it's not the mandatory requirement, or not the rule or regulation, but it gives certain type of guideline. In the future, probably those the requirements will be added to the standard in future, so that they are keeping certain provision to add this type of requirement optimization, so that what it says is you have to the overall optimize your system, cabling system, so that you can minimize the losses in the cabling system and overall design. So that is the requirement. And also you have to maintain minimum voltage drop. Those are the normal things which were in the earlier version as well. But new optimization requirement is mentioned in the appendix. So as the brand new requirement. And also that they discuss about several other requirements, like a power factor correction and the zoning, and also when we are using motors and the motor controls, what type of requirements are there. As I said, at the moment, these are guidelines where the designer can follow those guidelines. In the future, that will be made mandatory, but at the moment they are guidelines. And for the lighting requirements also, they are encouraging to use the movement detections and the BMI system, the building management systems for the installation. So likewise, we can minimize, we can use those type of new technologies to minimize the energy consumption in the building. So that those are new addition, even for the HVAC systems, how to design a HVAC system with the minimum power requirement. So what type of controlling should be there in the HVAC system, those are given as a guideline notes. So those are the new additions to the standard. So those are the major things which I detected as a major changes in the regulation, as I said, because I have not covered everything in the regulation. These are the highlights of the changes compared to the previous version. Now you can see even this ARC4 detection, SPD, those were not as a mandatory requirement in the previous versions. Those are now become mandatory requirement, and the risk evaluation and the earthing requirements, those are now become mandatory, so that you have to adapt those things in the new design. As I said, from January 1st, the 2019 onwards, whatever design you do, you have to follow this IET, the 18th edition, so that those are mandatory requirements. So that's all I'm going to cover. I think I have taken a little more time than 1 hour, so that if you have any question or anything, so now open to answer those questions.
Yeah, thank you, Dr. Asanka Rodrigo. It was a continuous flow of electrical engineering for 1 hour and 15 minutes. I'm very impressed because I couldn't be there for your last year's presentation. So learn a lot of things with the 18th edition. And I'm very thankful for agreeing to do this lecture and taking us through a lot of new things. And I'm also, I want to commend the participants, because at the beginning we had 79 and it went up to 82 at some point, and even now we have 77. So you all were a very disciplined crowd, because no one tried to switch on videos or mics, and also you had very big enthusiasm and interest to stay with us until now. It is 7 o'clock. It is the best time to raise some questions. I picked up all the questions in the chat box. So we'll first take them one by one. The first question was, is there any way of install hair dryer in bathroom? Dr. Asanka.
Yeah, actually, when you look at the bathrooms are considered as a special locations. So that when you look at the special locations, these bathrooms are layered in such a way that the zone 1, zone 2, and zone 3, and the outside the zone. So when you look at these zones, especially in the shower area, we consider as a zone 1. Then about, if I remember the correct value, about 1.25 meter away from the bath shower as the zone 2, and then 2.25 meter away from the zone 1 as the zone 2, then the outside zone. So the outside zone, you can install any equipment, but in the zone area, you cannot use normal equipment. So especially in the zone 1 and zone 2, you have to use the special equipment. But as I said, in the zone 2 area, where you can use the normal luminaire and other equipment, but if you are going with the SCLV equipment, then you can install it in that area. But the outside zone, you can use any equipment as in the normal installation. Even within the bathroom, if it is outside zone, then it's fine. But else, you have to use that particular special equipment like SCLV equipments.
Okay, thank you, Dr. Asanka. Hope the question was answered. Second question is, how many 13 amp socket outlets are permitted to install a given circuit, and how the MCB rating is selected?
Okay, that one, now we know that we are using the 13 ampere or what we call as a type G, the socket outlets and the plug tops in Sri Lanka and also even in the Europe. So as per the standard, there are 3 ways where you can install this the socket outlet. Mainly 2 ways. One is the ring circuit, or the other one is a radial circuit. When you look at the ring circuit, we have to use either 30 ampere or 32 ampere. Within 100 square meter area, you can use whatever number of socket outlet. There is no limit, so that it's basically consider the diversity within that 100 square meter area. So within 100 square meter area, you can use whatever number of socket outlet within that ring circuit. Other one is we can go with the 30 ampere radial circuit. So that about 50 square meter area, we can run with the 30 ampere, the radial 30 or 32 ampere radial circuit, so that there is no restriction of the socket outlet. Third category is where you can go with the 20 ampere radial circuit. So the 20 ampere radial circuit, you can wire within 20 square meter area. Within 20 square meter area, you can have any number of socket outlet. There is no restriction. Now in the new the standard is where there is no restriction to the the number of socket outlets, it's restricted by the area and the overcurrent protection. There are 3 overcurrent protection schemes. One is a 30 ampere pin circuit, other one is a 30 ampere radial circuit, third one is 20 ampere radial circuit. So there are no restriction other than the area restriction.
Okay, thank you, Dr. Asanka. The next question is, what is the minimum safe limit of IR for induction motor windings? Is it depend on working voltage?
Yeah, it's depend on the working voltage. A low voltage value, if I remember correctly, that will depend on the, because these, when you are checking the insulation levels, so those insulation levels will depend on the different voltage value. I cannot exactly remember what were the values, but there are the 3 different levels, like ELV systems and the LV systems and the high voltage systems. Therefore, each and every voltage, there is a minimum requirement. So those they have to comply with those minimum requirement for the IR values.
Right, thank you. Next question is, what are the special major considerations for temporary installations apart from the other permanent installations?
Yeah, as I said, if you have a movable or temporary, so that depending on the current rating, so that you have to have now, even in the new regulation, it's made compulsory to have RCD protection for the any movable installation. You have to provide the supply through a RCD, residual current device, with 30 milliampere the supply if it is a 30 ampere or lesser. The other things, okay, you can go with the normal the requirement, so that the depending, because when you look at the temporary installation, you have to check whether it is belongs to a special installation. There are certain like a temporary or exhibition location, those are categorized as a special location. So if you have those special, if the temporary installation is a special location, you have to comply with those requirements. Otherwise, you can go ahead with the normal way. But if it is a movable type things, then that should be protected with the RCD.
Okay, thank you. There was a request to share the webinar recording, so which we will do. We will share the webinar recording to all the emails with the registration details. Don't worry about it. And also they have asked whether the speaker can share the presentation. I don't think you need it because the recording will contain the presentation itself. And then next question is, are existing installations to be modified with these new additions to the new additions of the 18th edition?
Yeah, whatever the augmentation or whatever modification should comply with this requirement. It's very clearly says that, so that the modification should comply, because when you look at the alternation, there is a part in the IET wiring regulation, alternation or the augmentation of the installation. It's clearly says that whatever the prevailing or the current the rules and regulations should apply for the this alternation and the extensions. But the existing one, you can remain as it is. But if you do any modification, then you have to comply with the new requirements.
Okay, thank you, Doctor. Next question is auto reclosing type RCCB allowed to install, replace existing RCCB in a single phase domestic wiring?
Yeah, it doesn't matter whether it is auto reclosing or not, but you have to comply with the basic requirements. So that if you are complying with the basic requirement like delta I or the sensitivity and all the other requirements, the timing and all the other requirement, then that's fine. Because when you look at the auto reclosing, that will keep it for a certain times to the reclose it, so that because of that the requirement fulfill, but the basic requirement should fulfill. That is the tripping time and the tripping current. So if they are complying with those tripping time and tripping current, then there is no harm to go with the auto reclosing.
Okay, thank you. And next question is, if we connect all earth to a one single earth network, what is the minimum earth electrode resistance to be maintained?
So the earth electrode resistance matters only if you have TT system. In the TN system, the actually earth electrode that doesn't matter. That's why the standard is silent on that one. So because you have equipotential everywhere. That's why in the new standard they are not talking about anything any requirement for the TN the installation, because if you have a equipotential bonding that fulfill your requirement. But when you look at the lightning protection, the IEC 62305, that the recommends to have less than 10 ohms earth electrode requirement. So that is for the any building. If you have a lightning protection system, if you are connecting your lightning protection system for the equipotential bonding, then you have to comply with that requirement. But when you look at the TT system, in terms of the safety, there is a overall in order to that will depend on your RCD value. If you have a 30 milliampere RCD, you can go theoretically you can go something like the 666 ohms, but the standard limits it to 200 ohms. That is in terms of the safety. So that is the 30 milliampere. Likewise, for the 100 milliampere, 300 milliampere, and the 500 milliampere, you can calculate what is the required earth electrode resistance value for the TT. That is for the TT safety requirement. TN, okay, we are silent on the earthing requirement. So because it's a equipotential bonding. So if you follow that equipotential concept, so that that fulfill your requirements. But for the lightning, of course, the standard recommends to have less than 10 ohms.
Thank you, Doctor. Next question is, if we connect earthing of surge protection system to building earth, isn't there any impact to the equipment during surge?
Because when you look at the basic concept is the equipments are damaging because of the potential difference. So that's why you have to have the surge protection, because the surge protection, you have the UP value, that is the voltage protection level. So if you select the voltage protection level correctly by considering the insulation level, UW value of your installation, there won't be any problem of connecting lightning protection system to lightning protection over the air terminal to the earthing system, because that will create a equipotential. So that it's like your potential rise simultaneously, so that there will not be any the difference between the potential. So your equipments are damaging if there is a potential difference. So that potential difference is maintained to a safe value by the surge protected device. So that by connecting equipotential with the surge protected device, you will not get any problem of the lightning damages.
Okay, thank you, Doctor. Next question is, are there any special considerations to be met if the lightning earth and equipment earth are combined?
That is the same thing, I think. As I said, the only thing is, as I said, you have to have these two combined, because you have to have the SPD as well as you have to connect equipotential bonding. Sometimes if you do not select the correct SPD, then there can be problem. Otherwise, all the standards, what they are recommending is to go with equipotential with the SPD connection. So that all the data connection, all the power connection, everything you can install SPD, and you can connect them equipotential bonding, so that if you maintain your electrical installation like that, then there won't be any problem.
Thank you, Doctor. Next question is, how to install SPD to single phase circuit?
So as I said, that will depend on whether you go for TN system or TT system. So in the TT system, you have to have the 1+1 arrangement. That is, you have to have a live to neutral and neutral to earth. So that is a requirement. For example, if I use live to neutral as a 25 kiloampere, the neutral to earth should be 50 kiloampere. So if I use a live to neutral as 12.5 kiloampere, then the neutral to earth should be 25 kiloampere. So but in the TN arrangement, either you can go with the 1 plus 1, or you can go with the 2 plus 0. So like I showed in the presentation, whatever way you can go, but that will depend on your earthing arrangement. TT only 1 plus 1 or the 3 plus 1. The TN you can go with the 4 plus 0 or 2 plus 0. Whatever way, both arrangement can be applied for the TN arrangement.
Thank you, Doctor. Next question is, if a live wire touches a gas line in the building where at the entrance there is non-conductive material used, do we need to put equipotential bonding?
You have to, that's why in the new regulation, they have amendment the previous requirement. So what they are telling is, okay, you take care your building requirement, so that if there is something happen, because you have your supply system, the everything, so the protection and everything, the supply system will take care of that protection. So you have to give the protection for your building, so that you have to have the coordination there, so that if a live wire connect to the metal, the pipeline, so the within your building that will be take care if you connect them to a equipotential bonding. But the outside area, because those are coming through the ground, so that it's like a earthing arrangement, so that your live wire connect to the earth like that, so that should be taken care by your supply system, the protection arrangement. That is the concept applied in the new regulation.
Thank you, Doctor. Next question is there any necessary to do equipotential bonding for kitchen items which are in hotels, especially stainless steel items?
Yes, it's a must. You have to do.
Right. Thank you. And next question, what is the allowable length of the earth wire from SPD and the size of the earth wire?
Yeah, sizes are also, there is a guideline. I haven't shown it due to the time limitation. So for example, when you look at the class 1 SPD, you have to use 16 millimeter squared, class 2 6 millimeter squared, class 3 1.5 millimeter squared. Those are the minimum requirement for the SPD earthing wire connection. And what is the other question?
What is the allowable length of the earth wire from SPD?
Yeah, allowable
and
length
the size?
is,
Yeah,
allowable length is, when you look at the SPD connection, as per the standard, the total line, total lead length, that is from the face to the SPD and SPD to earth. So the total length should not be exceed more than 0.5 meter. So the maximum is where you can go the 1 meter in the worst case scenario, but the recommended value is 0.5 meter. So the total wire length should not exceed more than 0.5 meter. And the cable sizes are, as I mentioned before.
Yeah, and the balance part of that question is, can SPD be installed at sub-distribution within brackets inside the house panel where earth cable length is about 10 meters long?
Yeah, earth, that is not actually the earth cable, because what you have is you have to connect SPD to your equipotential bonding bar. So the length to the equipotential bonding bar, the total should be less than 0.5 meter. From the equipotential bonding bar to earth, the length, so you have to minimize as much as possible, because that can, if there is a earth fall situation due to the resistance of that conductor part and the earth electrode part, there will be a potential rise. So to minimize that one, you have to minimize the resistance in that part. But other than that, there is no the problem. But when you look at the earth connection from the equipotential bonding bar to your earth electrode, compared to the earth electrode resistance, this cable resistance is negligible. So that most of the cases, because of that, because the major component coming from the earth electrode, and because of that, earth connection resistance is immaterial or negligible. So, but it's always better to reduce that the cable length, or reduce means reduce the impedance part, so that either you can have, if it is too long, you can have the bigger cable, so that you can minimize the resistance in that cable. That is the requirement. Otherwise, if you can maintain that potential, then that is the touch potential of maximum 50 volts, then that is fine.
Thank you, doctor. Next question is what it means by dual coarse meters.
I am not aware. Dual core.
It spells as CORSC. I think it's wrong. What means by dual coarse meters?
I am not very aware about. Sorry about that. I am not aware that.
Right. We'll try to find the answer maybe later. Next question is, in regulation, it is mentioned that other socket outlets except SCLV and shaver are prohibited to use other sockets within a distance 3 meters away from zone 1.
Yes. That's why I mentioned. Okay.
Yeah. So I think it's a note, right?
Yeah.
It's not a question. Then what is the maximum ground potential rise GPR allowed?
There is no such requirements mentioned in the regulation, as I know. So
Yeah.
because the ground potential rise is depend on your resistance and the amount of the fault current. So that if you are maintaining the safety requirement, so that it doesn't matter the ground potential rise, because everything will rise. So that it's like when you are the standing on same potential. So only thing is you cannot maintain two potentials. So the ground potential rise, there is no limit that can go whatever value depending on your fault current or the current you are diverting to the ground.
Okay, thank you, doctor. And the last question, which was in the chat box, is do we want to connect metal doors and windows to equipotential system?
Yes, it should be. As per the regulation, it should be.
Okay, right. Thank you very much. And that was the last question in the chat box. I wonder whether there are any other burning questions, if any of the participants
even
have.
the question or comment even are welcome. So if you have any clarification or any additions, because it's a knowledge sharing, so that anybody can give any suggestion or anything.
Anyone wants to speak?
Yeah, hello. Hello.
Yeah, we can hear you. Yeah, Mr.
I'm
Bandu.
Bandu Lopez. This is my question. The chat box didn't come. I have noticed most LED fittings do not have an earth terminal to connect the earth. What is the position regarding this?
The LED, normally if you do not have a metal part outside, and then they will not, if you look at normal like incandescent type of ones where there are no any metal parts to the touch, they will not get the earth connection. But most of the other type of things where they are, when you look at the driver circuit itself has a earth connection, almost all. If you look at carefully, most of the driver circuits, they are coming with the earth connection. And also that is needed for the harmonic filtering as well, because there is the EMC filter, and in order to work that EMC filter, there should be a earth connection as well, so that the earth connection is provided for the driver circuit. And if the LED, the outer exposed conductive parts are there, then that should be connected to the common earthing. So generally the reputed brands are coming with the earthing connection.
Yeah, but doctor, I have noticed only two cables are coming from the driver, from the lighting fitting means plastic fitting like.
The plastic, as I said, if it is plastic, and if you do not have any metal enclosure or anything, then there is no way to connect the earthing connection.
Yeah.
So that in that case, you don't need.
Dr. Asanka, there was another question while you were discussing with Mr. Bandula. What is the size of the conductor used to connect metal doors and windows to the main earthing system?
There is a table given in the IET Wiring Regulation, depending on the certain requirement. So the equipotential bonding and the supplementary bonding minimum requirements are given in the standard. I cannot remember exact values, but the person who asks, he can refer the, even I can share the table, so that that's in the standard. So there is a specific table for the minimum requirement for the cables.
Right. So I think that was the last question we can take. It's 7:24. With the interest of time, we can call this session a day. And
Doctor, I have another thing to share with you.
Yeah.
You mentioned that the 18, I'm Ravi Rupasinghe. I'm Ravi Rupasinghe.
Yes, sir.
Yeah, actually you have mentioned that arc pole calculation has included in the 18 edition.
Yes.
Even 17 edition also, it didn't mention, but a lot of companies like very hazardous situation like chemical industry or gas industry, they concern about the arc flash calculation for their electrical systems, arc flash calculations. So is there any software or how you can calculate the arc flash boundary systems?
At the moment, there is no such kind of, as I know, there can be certain specific specific the products in by the specific manufacturer. Other than that, I am not aware about any software which is giving a common type of calculation. But what the standard says is, so if you have that type of a particular, if you look at that particular locations, those locations should be, it's a mandatory to have the arc flash detection.
Okay.
Like here, so that that guideline is given there, so that especially in the end equipment, final equipment, you have to have the arc flash. Other things, other location, as you said, you have to evaluate the risk and then calculate the install it appropriately. But in here, it says for the final circuits, with these type of locations, it's a mandatory to have the flash detection equipments.
Doctor, actually, I have done some what is called consulting for the Sri Lankan company. So they are asking the arc flash calculation for their safety regulations. So to maintain their safety regulations. So I have been done some calculation with them. So I find the calculation method with the internet. I saw that there are some software as well to calculate. That's I want to share with you.
Right. Okay. Thanks for. I haven't used it. Please share that one.
Thanks, thanks, Ravi, for your inputs. And there was another question, last question, I think. As tripping times are defined for RCBs, is there any tripping times defined for MCCBs and MCBs?
Sorry, MCCB?
As tripping times are defined for RCBs, is there any tripping times defined for MCCBs and MCBs?
When you look at the RCD is a residual current device. That does not mean that it is only for RCCB. RCCB is also a RCD. If you are using MCB for the RCD, because when you look at the different type of earthing arrangement in a TN system, you can use either RCCB or even MCB as your RCD device. So that when you look at the regulation, what the regulation gives is the RCD tripping times. So whatever device you are using, so if you are using it for the earthfall the protection or earthfall detection, then they should comply with that requirement.
And another part to that question, are AFDD mandatory for healthcare premises?
Healthcare is not the listed here, because if there is any the fire propagation risk or any fire risk within the premises, then you can go, because what you have to look at is whether there is a fire risk. So due to the arc flash. So if so only you can go, otherwise normally in the healthcare, like even for the operation theaters, most of the locations are designed as IT systems where you don't want to disturb the electricity supply. But if you have a particular the risk of arc the flashes and the propagation of the fire, then you can install it, but that will increase the risk of nuisance trippings.
Thank you, Dr. Asanka. I think it was the last question. It was a great 2 hours. I mean, exactly 7:29. So we started at 5:30. I'm very thankful for Dr. Asanka Rodrigo for conducting a very healthy and very comprehensive presentation on IET wiring regulations. And we could not appreciate you in person, but virtually online we appreciate on behalf of IET Sri Lanka Network.
Opportunity is appreciation. Yeah.
Yeah, and we hope you will carry on with this task in years to come for IET Sri Lanka Network, probably with a new addition to this. And I thank Ravi also for coordinating with Dr. Asanka Rodrigo for bringing him for this particular lecture. And still we have 64 participants. I commend and appreciate all your very enthusiastic participation, and there were more than 25 questions. And there's another comment here. I think healthcare premises falls in the category of sleeping accommodation, aren't they? Is it, Doctor?
Healthcare means normally when you look at the wards and other things, of course, you can consider as the sleeping accommodation, but operation theaters, what I mentioned was operation theater. So those are the special kind of locations. Other locations, of course, you can consider as the sleeping accommodations.
Okay. Thank you very much, Doctor. And thank you, my IET colleagues from the Expo, Dr. Anuradha, for being a co-host. And I think Dr. Anuradha has recorded the presentation, and our General Secretary Harshana will email to all the registered participants this recording. And thank you very much once again, Dr. Asanka Rodrigo, and all who are participating. We'll see you in another webinar in the month of June with another exciting topic. Until then, I say good evening to everyone, and have a pleasant night. Thank you very much.
Thank you, and bye.
Thank you, Doctor. Thank you, Dr. Lalit,
Thank
Dr.
you.
Asanka.
Thank you, everyone.